This video demonstrates the use of the Wings OODT workflow system to allow end users to solve complex analytic tasks with big data under a deadline. More specifically, I will be explaining how a system can be used to assist end users with selecting algorithms based on speed of execution. For example, as we mentioned in our paper, if a user wants to do topic detection, he or she can use the LDA algorithm. However, there are many alternatives of LDA, like Mallet, online LDA, parallel LDA, etc. All these algorithms say they are fast, but if a user has a deadline and a lot of data, which algorithm can be chosen to get a valid answer on time? This problem gets exacerbated by big data, since the difference in performance is far greater. In addition, the end user might not know what visualizations to use, how to format the data, etc., which a workflow system can assist with. In order to provide the mentioned assistance, first, we would need an expert to write and describe the code to encapsulate algorithms, format input data, do pre-processing steps, etc. This is the Manage Components interface of the system. Here we can see the Train Topics class of components. This class of components takes in at least one input data file, outputs at least a topics file, and takes in the number of iterations as a parameter. In this class of components, we have implementations for Mallet, online LDA, and parallel LDA. Second, we would need the expert to create workflow templates out of these components, which are multi-step methods that the expert or a user would use. This is the Run Workflows interface of the system. We have opened the topic detection workflow, which uses the train topics and the format dataset class of components that we mentioned earlier. It also includes some pre-processing steps, like stop words and small words, and a visualization step. We're working with Stanford to develop a visualization component based on D3. Third, the expert runs the system using several training datasets, and the system creates a performance model of the workflow based on the time it takes to run that workflow. Now I will show an interaction with the end user. For this workflow, the user can pick a dataset, say Reuters R52 train. This dataset would be fetched from the OODT file manager, where it would have been uploaded after the ETL process. Note that the workflow has other inputs as well, such as a words file with certain stop words that should be removed from the input dataset, a size parameter indicating the minimum size of words to keep in the input dataset, and the previously mentioned iterations parameter. The system can also assist with setting inputs and parameter values. Click on Suggest Data to get the system to give suggestions for the datasets to use. You can choose and use selected data. Then click on Suggest Parameters to get the system to give parameter suggestions. After the whole form is filled out, we can go ahead and run the workflow. At this point, the intelligent workflow system considers all alternative algorithms for the train topic step. It is able to use sophisticated logic rules to determine if certain algorithms do not work well for certain kinds of data. As a simple example, you can see that the system was able to select the appropriate format dataset for the particular train topics dataset. Also notice that the system shows the different runtime estimates for these workflows. These estimates are based on modeling historical run data as mentioned earlier. We can go ahead and run a particular workflow. This is the Access Results interface where you can monitor runs and view results. Once the workflow has finished execution, we can view the output files. Now that the workflow has finished execution, we can click on the plot image to see the final output. This visualization shows common words on the left and several topics on top. The circles indicates how often the words appear in the particular topic, the size of the circle that is. At the moment we are just showing example visualization that come out of the Termite D3 software, but we are working with them to encapsulate the software so it can be invoked as a workflow component. That's the end of the video. Thanks for watching.